The orbiter, which is also known by the informal name Mongol-Yan, meaning Mars craft, is a 1,337 kilogram satellite about the size of a small car. The search for methane in the Martian atmosphere is probably the most significant part of the Mars orbiter mission. Martian methane has been detected by sensors on Earth, but NASA's robotic rover Curiosity has failed to find the gas during its time on the planet. The Indian spacecraft will also examine the rate of loss of atmospheric gases to outer space. This could provide insights to the planet's history billions of years ago. The probe has been lifted off by India's very own PSLV C-25 rocket using alternate solid and liquid propulsion in 4 stages. Once the solid fuel is ignited, the resulting thrust cannot be regulated or turned off. But for the liquid fuel, the thrust can be regulated and the engine can be turned off or on. The orbiter is separated from the PSLV C-25 rocket and put into an elliptical Earth parking orbit. As the orbiter goes away, the velocity decreases, but as it comes back, the velocity increases because of the Earth's gravitational pull. The 440N engine is fired for a short duration when orbiter is closer. That is when its velocity is high. This raises the orbit and increases the velocity with the least amount of fuel. After 6 main engine burns, the orbiter gains escape velocity to escape the sphere of influence of Earth. Now, the Sun is much more massive than any of the planets, and its gravity dominates the solar system. Only very near to the planets does the planetary gravity become stronger than that of the Sun. This region around the planet is referred to as the sphere of influence of that planet, and the velocity required to escape the sphere of influence is called escape velocity. When Mars is in the right position, the orbiter leaves Earth in a direction tangential to Earth's orbit. This process of setting the orbiter in a trajectory which will cause it to arrive at Mars is called transmars injection. Now, according to Newton's first law of motion, the orbiter will continue to stay in motion unless acted on by an outside force. Therefore, fuel will be used only to correct the trajectory of the orbiter, and this process is called trajectory correction maneuver. It will reach Mars on September 24, 2014, and will be inserted into the Martian orbit. To make this happen, the angle between Earth, Mars, and the Sun should be 44 degrees approximately. Such arrangements recur at intervals of about 780 days. If for some reason they failed to launch the probe on November, then the next opportunity will be in January 2016, May of 2018, and so on. The phenomenon used for detecting the speed of motorists on highways is the same as the one used to estimate the velocity of the orbiter. You see, radio waves are continuously sent out to the orbiter for communication with Earth. While orbiter is moving away from the Earth, each successive radio wave has to travel farther to reach the orbiter before being reflected and redetected back on Earth. As each wave has to move farther, the gap between each wave, the wavelength, increases. This change in wavelength is used to compute the velocity of the orbiter. This phenomenon is popularly known as the Doppler effect, in honor of the Austrian physicist Christian Doppler. To reach Mars, the orbiter follows a heliocentric path, meaning orbit around the Sun. The shortest distance between Mars and Earth is 54.6 million kilometers. Launching it in the shortest possible route to Mars and then decelerating to match the planet's speed would require an extremely large amount of fuel. The route which requires the least amount of fuel is an elliptical orbit of about 680 million kilometers, which forms a tangent to the Mars and the Earth's orbit around the Sun. This kind of transfer is called a Hohmann transfer. The cost of this mission is 450 crore rupees. Considering the distance between Earth and Mars is 400 million kilometers at the farthest, the cost of Mongol-Yan expedition is slightly over 11 rupees per kilometer. Or, as some may point out, cheaper than what auto rickshaws charge in Mumbai. Should India really be exploring Mars when 1/3 of the population of India, about 400 million people, live below the poverty line? Well, instead of answering this question, I would point out some interesting things. The budget of Bollywood movies is 25 to 75 crore rupees or more. PM's foreign trips since 2004 cost 640 crore rupees. The Sirdar Patel statue is estimated to cost 2,500 crores, and the Diwali firecrackers market is worth rupees 5,000 crores. In my opinion, exploring space is far more important than producing meaningless movies or building lifeless statues. And if you liked the video, please give it a thumbs up, and for more videos, hit the subscribe button. And if you have a topic or question for the next video, then leave it in the comments below, because that's how we roll. And of course, this video is in collaboration with Untamed Science. Those guys are awesome. Check out their channel for more cool science videos. Check out their channel. Hey. Oh, and this video, it's a collaboration between Untamed Science and me. Oh, and this... Oh, me. It's just right over. And this video is in collaboration with Untamed Science. Check out their channel for other cool science videos. Sweet.